With our code improvements out of the way, let's dive back into some internals of Flutter, though this time internals you can actively take advantage of or which you will need from time to time. And that's the lifecycle of a widget. Now what's that? Now we'll actually have a different lifecycle for the different types of widgets we have. For a stateless widget, the lifecycle essentially is that it's created, and of course, as you learned, widgets are recreated multiple times when the build method of their parent widget is called. And that means the constructor is executed and then the build method is executed. That's what you already learned. For stateful widgets, we also have the constructor function being called, but then there we also have create state being called to create that state object, and that's now where the interesting part begins. Inside of that state object, you can add an init state method which will be called automatically. So that's a reserved method name for a method that is executed automatically by Flutter when the state object is created for the first time. And remember that the state object is managed independently of the widget, so when the widget is rebuilt, init state will not run again. It only runs when the state is created for the first time. Thereafter, we have the build method which executes. Now you can always call setState to update the widget and rebuild it. And in that case, or when the widget is rebuilt because its parent widget build method was called, in which case all child widgets are rebuilt as you learned, then did update widget executes. So that's another method you can add in your state, actually in the state object, which is triggered whenever the widget that belongs to that state was updated. And then thereafter again build runs. Now, if a widget is destroyed, so if it's removed because you rendered it conditionally and the condition now is false, then dispose is called. So all these special methods, init state, did update widget, dispose, are all methods you can add to your state object, and they run when the state is created, when the attached widget changed, or when the state object is cleared, is removed, which happens when the widget is removed. So not when the widget is rebuilt, so when it's deleted and a new one is added. In that case, the state would stick around. But if the widget is removed and is not rebuilt, because again, it might have been rendered conditionally and the condition now returns false. Let's have a look at this in practice. Back in our code, let's pick a nice widget where we can add these life cycles. And the new transaction widget isn't too bad for that, because it's a widget which also gets removed when we close this modal here. Then when we close this widget will be removed, and therefore this is a good candidate for implementing these different lifecycle methods. So as you learned, you implement them in new transaction state. And to get a full overview of what's happening, let's actually start with the constructor of the widget, so not of the state but of the widget. So there we can now print constructor new transaction widget. Now let's also print when create state is called, and for that I'll convert this from a single expression function here into a function with curly braces where we can have more than one expression, because of course I want to create my new transaction state and return it here. But before we do that, I also want to print create state in new transaction widget. And I also have to remove the semicolon after the constructor. So now we have print statements in the widget. Let's now go to the state. There we can add a constructor. We don't need it here, but we can add it, of course. So let's add the constructor by repeating the name of the class, which is underscore new transaction state. And here we can print constructor new transaction state. Now you learned that there is an init state method which you can add. And here my IDE helps me. When I type init, I can hit enter and it adds init state. Override is added because init state is implemented by the state class we're inheriting from, we're extending. And if we add it on our own, we add override to make it clear that this is not a mistake, but that we deliberately want to add our own, which means that the one in the parent class, state, which we're extending, is not called anymore, but our own one is called. And hence here, you also have to do something which you haven't seen before. We're calling super.initState. Super is a keyword in Dart, which refers to the parent class. So we inherit state here, and that means that when the new transaction state is created, a state object is created as well. And super here refers to that parent object, to that state object, basically, and makes sure that we also call init state there, so that not just our own init state function runs, but also the one that was built into state. Now, before that is called, however, you can do your own initializations. And often that is, for example, used to make a HTTP request and load some data from a server or load some data from a database, anything like that. It's also something we'll do later in the course once we reach the HTTP module. For now, all I will do here is I will print init state, just like this, so that we can see that this really executes. Now, it's also worth pointing out that the official docs now state that you should call super init state first and therefore put your code after super init state, not before it. Now, it won't make a difference because what happens in super init state, so in init state of the parent class, is very trivial and only matters for debugging, has no impact when your app runs in production, and you find more details about that in the next lecture. In this course, I mostly call my code before super init state, and that's also what you find in a lot of official examples, which is why I followed this practice, but be aware that the official recommendation now is that you call super init state first. And that's also the case for other lifecycle hooks I'll show later. When you call super.something, call that first and have your code after that. However, it actually won't make a difference. There is no code running in these super methods that would not work or run differently if you run your code first. That's really important. Now, I also mentioned that there is another method, did update widget. We can add this as well. Now, again, this is a method which also exists in the parent class. We override it deliberately, and just as with init state, we have to call the method in the parent class. Important, you get an argument here, and that is the previous widget that was attached to the state. As I mentioned, this gets called when the widget that is attached to the state changes, and then Flutter actually gives you the old widget so that you, for example, could compare it to the new widget. Because remember, you have that special widget property which you can use in your state. It always gives you access to your related widget, to your attached widget that belongs to that state. Widget will now automatically refer to the updated widget. So let's say the widget updated because it received a new argument in case it took any. Then here you could get access to the new widget, and if you wanted to compare it to the old one, Flutter gives you the old one as a convenience feature here as an argument. In my case here, I only want to print did update widget though to see when this runs. Now, last but not least, the state also can get removed at some point of time, and for that we can add dispose here. Again, we override a built-in method, we have to call it on the parent class, and then here we can print dispose. With that, let's refresh the entire app here and let's see what we get. Clear the debug log so that we can clearly see everything, and now let's open that bottom sheet. It comes up, and if we now go back, we see what happens is that the constructor of the new transaction widget is called, which makes sense because the new transaction widget is part of this modal sheet. And therefore this is created. Then create state is called. That also makes sense because that is what Flutter does for stateful widgets when it creates the widgets. In that state, the constructor is therefore called. Makes sense because we're creating our own instance of our state class here and we're calling the constructor here ourselves. Hence, of course, we see the log here. And then thereafter you see init state is called. That's done by Flutter. And now what you also see here, the constructor of new transaction was called again. Now that does not happen because we're using a stateful widget here or anything like that. That simply is a behavior Flutter has here for this modal bottom sheet. It does call this builder function here in show modal bottom sheet, this builder function, which returns a new transaction. It does simply call this builder function more than once. Now, the good thing about this, indeed a bit weird behavior, is that it shows us that the constructor of new transaction is called again, because if this builder function here runs again, all these widgets get created again, so a new transaction gets created again. But what we see now also is that create state is not called again, and therefore the constructor of the state and init state is not called again, because, what I mentioned, the state is managed as a separate object, and when the widget rebuilds, the state is not recreated automatically. Instead, it sticks around and simply the reference of the element which manages the state, is updated to point at the new widget. What is called, however, is didUpdate widget. This is called because our widget updated. The connected widget, the new transaction widget, was replaced with a new one because of that duplicate call in show modal bottom sheet. And therefore we get didUpdate widget executed because the widget attached to the state was replaced. And that's why this is a convenient example. Because of this strange show modal bottom sheet behavior, we actually see both init state and didUpdate widget. Now when I close this by clicking somewhere on the backdrop, you now see show modal bottom sheet really goes into a frenzy and recreates this widget a couple of times, probably because of the animation it's playing, this slide down animation, which also uses a stateful widget behind the scenes, one built into Flutter to update this. It recreates the new transaction widget a couple of times. As you see, this triggers didUpdate widget, but then in the end, you see dispose is called, because in the end, once the animation finished playing, this widget is gone and it's not on the screen anymore, and therefore the element and the render object is removed because that needs to be removed. You don't want to see it on the screen anymore, and hence dispose is called because when the element is cleared, the state object is cleared as well and therefore removed. Now that is the life cycle of widgets and most importantly of state. Now, when would you use that? As I said, init state is often used for fetching some initial data you need in your app or in a widget of your app. DidUpdate widget is probably used way less often. You could use it if you know something changed in your parent widget and you need to refetch data in your state. So if you're fetching data from a database and you received a new ID in your widget, which is attached to the state, and for that ID you want to fetch new data, you could do this here in didUpdate widget with the information that you have in a new ID. And dispose is great for cleaning up data. Let's say you have a listener to a real-time internet connection which sends you new messages because you're building a chat application or anything like that. Then you want to clean up this connection to your server here when your widget is removed so that you don't have that ongoing connection in memory even though you have no widget anymore. This will lead to strange bugs and also to memory leaks. So cleaning up listeners or live connections, that is something you would often do in dispose. And that's it for the widget lifecycle. For now, we'll not use too many of these methods, but later we'll definitely need init state once we start interacting with web servers.